So in this video, we're going to start working on drawing Lewis dot structures for ions. Let's look at this first example, the Lewis dot structure of the hydroxide ion. So oxygen is in group 6. It's going to give us 6 electrons. Hydrogen's in group 1. So we get 1 more electron from the hydrogen. And because the hydroxide has a -1 charge, remember that 1 is understood. Negative means it gained an electron. So I'm going to do 6 plus 1 plus 1 more electron because of that negative charge. So I have a total of 8 electrons to build this structure. There's no central atom, it's just 2 things. So I'm just going to connect the oxygen to the hydrogen. We want to satisfy the octets. So right now oxygen has 2 electrons. So I'm going to put 6 more around it. So I have 2, 4, 6, 8. Hydrogen, remember, just wants to do that one single bond. Hydrogen's good to go. 2, 4, 6, 8. I've used exactly 8 electrons. So this is a correct structure. The last thing here that's a little bit different than the previous examples is that because it's a charged species, we want somebody who just looks at this by itself to know that it had a negative charge. So anything that has a charge needs to have square brackets, and then you're going to put the charge on the outside of the square brackets. That part's really important. All right, let's continue. We have boron. Boron's in group 3. 4 hydrogens. So group 1, so 1 electron times 4. And then there's a -1 charge. The species picked up 1 extra electron. So we'll do plus 1 electron for a total of 8 electrons. Hydrogen can never be our central atom because it only bonds once. So I'm going to put boron in the middle. Connecting my 4 hydrogens. That's pretty cool because connecting those 4 hydrogens to boron satisfies boron's octet. So it looks like we're good to go on the octet. Let me just check that I used 8 in total. 2, 4, 6, 8. So that part's good as well. Last thing, again, because it's charged, we need square brackets. And we'll put the negative outside of the brackets. So in our next example here, we have ammonium. It has a positive charge. Remember, a positive charge means that the compound or the species lost an electron. Therefore, when we do our electron math, we need to subtract an electron. So we have nitrogen, which donates 5 electrons. It's in group 5. 4 hydrogens, that'll give us 4 more electrons. And then I'm going to subtract 1 electron because of that positive charge. So altogether, I have 8 electrons available to build my structure. Nitrogen is going to be in the middle. I'll connect those 4 hydrogens. And that satisfies the octet of nitrogen. I have 2, 4, 6, 8. I have 8 electrons around that nitrogen. Hydrogen's good. And I've also used exactly 8 electrons. So the last thing to do here would be to put the charge on the outside of the square brackets. All right, let's continue. So we have carbon, which donates 4 electrons, 3 hydrogens, so each one donates 1 electron for a total of 3 electrons. Oxygen's in group 6. And then we have the -1, which means that we're going to add 1 electron to our math here. So altogether, we have 14 electrons to build our structure. We have multiple candidates for the central atom. Hydrogen can never be a central atom, but carbon and oxygen can both be central atoms. Who's the better choice? Remember, you always want to put your least electronegative atom in the center if you can. So carbon is a much better choice for the central atom. It's better at sharing those electrons. So carbon's in the middle, and I'm just going to attach everybody to carbon. That satisfies the octet around carbon. Carbon has 2, 4, 6, 8. Oxygen, however, only has 2. So let's fix that. So we need to put 6 more electrons around oxygen. Now the octets are satisfied. Let's make sure we only used 14. 2, 4, 6, 8, 10, 12, 14. Perfect. All the octets are satisfied. We used 14 electrons. The last thing we need to do here then is put some square brackets and put the negative charge on the outside. Moving up, we have hydrogen with 1 electron, carbon, 4 electrons. In this structure, we have 2 oxygens. So I'm going to do 6 electrons times 2. And it does have a negative charge, so I'm going to add 1 more electron. So 5, 6, 12, I'm getting 18 electrons altogether for this structure. Carbon again, when we see carbon, carbon is typically your central atom, if it's there. So let's put carbon in the middle. And then I'm going to attach hydrogen to that carbon, and I'll attach the 2 oxygens. Let me satisfy all the octets, and then I'll go from there. So right now, carbon has 2, 4, 6. Put 2 more electrons on my carbon. The oxygen only has 2, so I'll put 6 more electrons around oxygen. And there's a similar situation for this oxygen. It has 2, so I'm going to need to put 3 lone pairs around this oxygen. Octets are good. Let me do a count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's not good. We used 20 electrons, but we only had 18 available. Remember, when that happens, that means we have a double bond or a triple bond in our structure. So let's cross this out and try again using a double bond. So I'm going to connect everybody the same, but I'm going to double bond just one of my oxygens. See if I can get us down to 18 electrons. So now carbon has 2, 4, 6, 8. So carbon doesn't need any electrons when the oxygen is double bonded. This oxygen has 2, 4. So I'll add another 4 electrons around that guy. This oxygen has 2, so I'll do 4, 6, 8. Octets are good. 2, 4, 6, 8, 10, 12, 14, 16, 18. So I've used exactly 18 electrons, and the octets are good to go. Last thing I need to do, since this is a good structure, this is my final answer. I want to put square brackets, and I'm going to put the negative charge there. So we definitely can have double bonds in our charged species. Let's do another one. Nitrogen will give us 5. Oxygen has 6 valence electrons. And I have a +1, positive to lose. So I got to subtract 1 electron. So we have a total of 10 electrons. So it's just 2 things. So I'll just connect those 2 things. Complete the octets. I'm going to add 6 electrons around oxygen and 6 electrons around nitrogen. And let's count. Let's make sure we only use 10. 2, 4, 6, 8, 10, 12, 14. We used way too many electrons. Let's try a double bond. So So I'll cross this out because it's wrong. I'm going to try to draw it again, this time with a double bond. With the double bond, the oxygen has 4 electrons around it. I'm going to give it 4 more. Same thing with the nitrogen. It needs 4 more because it currently has 4. Let's check our math then. Did we use 10? 2, 4, 6, 8, 10, 12. We still use too many electrons. Well, let's then try a triple bond. So with the triple bond, they each have 6. So we'll just do 1 lone pair on the nitrogen and 1 lone pair on the oxygen. Now 2, 4, 6, 8, 10. Use 10, that's perfect. And I'll finalize my structure by doing square brackets with a charge on the outside.